In mathematics, we work with expressions all the time, and expressions are typically made up of constants, variables, and of course, operations. Constants are just static values, numbers in general, like 2, 15, whatever. Also, values like this, like pi, which is just a number, it's just a decimal number. And then also things like this. So the square root of 2 is this number here. We like to write square root of 2 sometimes, though, so that we don't have to write this, just like how we like to write pi instead of this number. But those are all constants. They don't change in value. Variables, of course, on the other hand, can change in value. We don't know what the value is until we either solve for it or we put something in. And these are normally used with letters. X and Y are the classic ones. We also will use other alphabets, like the Greek alphabet for alpha here and epsilon or beta, things like that. So here we have two expressions in mathematics. We have variables, right? We have constants here, 3, 2, 16.5, and variables x, y, z, a, b, n, m. Those are all variables in this thing. And for this one, we have constants 2, 3, 3, 4, and 12, and variables, which is x here. Now, within these expressions, we have terms. Terms are separated by addition and subtraction. So here we have a term. Here's another term, and this one is the last term. There's 3 terms in this first expression. In the second expression, we're looking at the overall expression, and there are only 2 terms. We have one here and one here, because there's only this single addition in the overall expression, right? These are multiplying together. You can, however, look within this expression, or within this multiplication here, inside the parentheses, and say there's one term there, one term there, one term there, one term there. Now, within terms, there are factors, and factors are separated by multiplication and division. So within this first one, we have 3x, y to the 7th, and z. There's 4 factors all here. We have 2, a, and b. Those are all each factors. 16.5, n, and m. Those are all factors. And of course, for this one, we have this is a factor, and this is a factor, because within this term, we have two things multiplying, and that's going to be this whole thing here. This multiplication, so it's going to be this entire portion in parentheses, and this entire one here. This term, you can think of 12 as a factor, because 12 is 12 times 1. And so 12 is a factor by itself. It's just the only factor in that term. Now, we can solve expressions if we know what all of the variables are. So, like, it tells us what, in this case, what x, y, z, a, b, n, and m are. We can solve this for a single value if we know all that information. And of course, to do that, we're going to use order of operations. PIMDAS is what we talked about before, but because we talked about absolute values and even the fact of square roots, these are what grouping symbols are. So grouping symbols are parentheses. You'll see brackets in mathematics. You'll see absolute value bars with something on the inside of them, right? And then the square root symbol is also a grouping symbol, where you're going to simplify the stuff inside first. Exponents, of course, are powers of like 2 or 3 or 5 or whatever. But also, the square root symbol is actually also an exponent, so it's going to be done at the same time. Multiplication and division. Division is just another way of writing multiplication. Mathematically speaking, they're the same operation, just slightly different in what we're talking about. And then addition and subtraction, the same idea. Subtraction is really just addition with slightly different setup. So multiplication and addition are there. I like to use the acronym GEMA instead of PIMDAS, because GEMA kind of encapsulates the entirety of what you're talking about. So for these expressions, we know what the variable is. So I'm just going to plug this number into the expression and simplify it using order of operations. I'm going to plug it in with parentheses. So I'm just going to replace the x with what x equals. In this case, x equals 7. So I just changed x to 7. And now these parentheses are just there for the inputting of the x. So I need to do these parentheses first, as grouping is the first order of operation that we have to do. So I want to do 7 plus 3 first. And then these parentheses are just there for clarification. It's 10 cubed, not 210 cubed, if that makes sense. So exponents is next. 10 cubed is 10 times 10 times 10. 1,000. Okay, no more exponents, so multiplication is next. 2 times 1,000 is 2,000. And finally, addition and subtraction is done last. 2,001. That's my answer there. All right, for this next one, a little bit more involved. B is -2. That whole thing is cubed. And there are lots of grouping symbols here. A fraction bar is a grouping symbol, so we need to do this stuff first. We need to do this stuff, and we need to do this stuff each individually, since those are all grouping symbols. Okay, because I have to do these all first, I can actually simplify them all at the same time. So I'm just trying to look for one thing to do in each one of these groups and do it at the same time, just so I don't have to write so much stuff down. Inside this, I still have to go through order of operations. Multiplication is done before addition. So 3 times 5 is 15. Okay, here, I need to do the parentheses first. -2 plus 5. That's going to end up being -2, and then we're going to go right 5 units. So -1, 0, 1, 2, 3. And then here, I need to do the exponent first before I can do the subtraction. -2 times -2. Negative times negative is positive. 2 times 2 is 4. Okay, I still have parentheses around this, and this. So I'm going to choose one thing on each again and do it at the same time. -11 plus 15, we start at -11 and we go right 15 units. That's the same thing as saying 15 minus 11, which is just 4. The exponent I can do here, 3 times 3 times 3 is 27. And 4 minus 15, we start at 4. We go left 15 units. It's going to go forward, then 3, 2, 1, 0, and then 11 more. So this is going to be -11. This is an exponent. And this is just division here. So this needs to be done first. The square root of 4 is 2. 2 times 2 is 4, so the square root of 4 is 2. So we have 2 plus 27 over -11. And of course, to add these two fractions together, well, first off, I can pull this negative out in front. Well, I'm going to do that up here, just to simplify some of the stuff I said. And plus a minus becomes just a minus here. I need to get common denominators to subtract these fractions. So I need to multiply it by 11 on top and bottom. That's going to give me, let's just put it over here, 22 over 11 minus 27 over 11. I can subtract the numerators, keep the denominator. 22 minus 27, we start at 22, we go to the left 27 units. That's going to be -5. So -5 over 11 is my final answer there. Okay, this one's a little bit simpler. 2 squared plus 2 minus 15. Parentheses don't actually mean anything here. They're just there for clarification. So I need to do exponents first. 2 squared is 4. And then addition and subtraction done left or right. 4 plus 2 is 6. And 6 minus 15, we start at 6. We go left 15 units. So it's going to be negative 9. All right, for this one, let's plug in the negative 2. We get 3 times negative 2. The absolute value of that plus negative 2 cubed over negative 2 minus 2 squared. Okay, same kind of idea as this one here. I need to do all these things individually before I can do anything together. This one, positive 3 times negative 2 is negative 6. Negative 2 cubed is negative 2 times negative 2, which would be positive 4 times negative 2 again. Positive times negative is negative. 2 times 4 is 8. And after you do this negative 2 minus 2, we start at negative 2. We go left 2 more units. That's going to be negative 4. That's being squared. Okay, I still have to do this before I can do anything here. The absolute value of negative 6. Negative 6 is 6 units away from 0. So it's going to be positive 6. And then negative 4 times negative 4 is positive 16. This is going to be negative divided by positive is negative. And 8 divided by 16 can simplify top bottom by 8. Be 1/2. Plus a minus is going to be minus 1/2. Once again, to subtract fractions, I need to get common denominators. So I'm going to get times by 2 over 2. It's going to be 12 over 2 minus 1/2. Or 11 halves as my final answer there. A formula is an equation that depicts some relationship between variables. Formulas are very important in mathematics, and as they describe, real relationships that are useful for different fields. A lot of sciences use formulas. So for instance, the volume of a sphere can be written as the radius r. The volume is this. And what is the volume of a sphere with a radius 2.3 inches? Well, that's just saying, what is it when r equals 2.3? For that, we just plug r into here. So we have 1/3 times r cubed plus r cubed. Okay. Order of operations still applies here. We're going to simplify just this portion here. We're not going to worry about this v equals portion. Just simplify this expression using order of operations. So grouping symbols are always first. We're going to have to do this thing first, right? And inside these parentheses, we need to simplify the exponents first. So 2.3 cubed is going to be the first thing we need to do. Use a calculator for that. I'm getting 1/3 times 12.167 plus 12.167. Okay, I need to do this multiplication first. 1/3 times 12.167 is 4.056. I'm just rounding to 3 places there. 12.167. And now I can do this addition in the parentheses. So v equals pi times 4.056 plus 12.167. That's going to give me 16.223. And now I can multiply this by pi. So multiplying that by pi on the calculator. I'm not using 3.14, I'm using the actual pi symbol on the calculator. That's going to give me 50.9, I'll do 3 places, 66. as the volume of the sphere. The cost of gas C for driving D miles, with average miles per gallon, your car gets average miles per gallon R. And if it's a price per gallon P for gas, is this formula here. So what's the cost for driving 152 miles? So D is the miles. Average miles per gallon of 29. And the price per gallon of 3.43. So the cost is the distance divided by the rate, the gas mileage rate, times by the price per gallon. Okay, I need to do multiplication division left to right. So I need to do this first. 5.24, and that's multiplying 3.43. I rounded the 5.24 to two places. So I'm going to do 5.24 times 3.43, and then I'm going to round this two places because this is a dollar amount. 97. It costs $17.97 to drive 152 miles with an average 29 miles per gallon rate, and at $3.43 per gallon. Okay, so according to Google Maps, Los Angeles to New York is about 2,800 miles. What is the cost of gas if you get 35 miles to the gallon? And 370 is the price per gallon. So here, D equals 2,800. R equals 35. And P equals 3.7. So I can still use the same exact formula. The formula doesn't change. Only these numbers that I'm using changes. That's the power of a formula. So the distance is 2,800. R is 35. And the price is 370. I still need to do 2,800 first. 2,800 divided by 35. I get 80 for that. And multiplying by 3.7, I get $296. That's the cost for doing that trip. Okay, the potential energy of an object is its mass in kilograms times the height, the meters above the ground at sea level, and then times by the acceleration due to gravity, which is 9.81 meters per second squared. The resulting unit is joules. That's the unit for energy. And what is the formula? So the formula is, it said the potential energy, so I'm going to write it as potential energy of an object is the mass times the height in meters times the constant acceleration due to gravity, g, which is just 9.81, times by 9.81. So that's the formula there for potential energy. What is the potential energy of a wrecking ball with mass 2,300 kilograms that is 10 meters off the ground? So the mass is 2,300, and we're assuming that the height is 10 meters off of sea level ground. So the potential energy of this wrecking ball is going to be 2,300 kilograms times the height, which is 10 meters, times 9.81 meters per second squared for gravity. Going left to right, 2,300 times 10 times 9.81. It's 225,630 joules. That's how you write the symbol there. How much potential energy does a tennis ball of mass 0.058 kilograms have on top of the Burj Khalifa, which is 830 meters tall? So potential energy is the mass times the height in meters times the acceleration due to gravity. Okay, 0.58 times 830 times 9.81. We get 472.25 joules. Still a whole lot less than a wrecking ball. It's only 10 meters off the ground. Even though the height is extremely, is so much farther. It's like 83 times as far off the ground.